So what's the title of this section is transposes and permutations. Okay. So can I say now, where does a permutation come in? Let me talk a little about permutation. So that'll be up here, permutation. So these are the matrices that I need to do row exchanges. And I may have to do 2 row exchanges. Can you invent a matrix where I would have to do 2 row exchanges and then it would come out fine? Yeah, let's just, for the heck of it, so I'll put it here. Let me do 3 by 3s. Actually, why don't I just plain list all the 3 by 3 permutation matrices? There are a nice little group of them. What are all the matrices that exchange no rows at all? Well, I'll include the identity. So that's a permutation matrix that doesn't do anything. Now, what's the permutation matrix that exchanges? What is P1, 2? The permutation matrix that exchanges rows 1 and 2 would be 0, 1, 0, 1, 0, 0, right? I just exchanged those rows of the identity, and I've got it. Okay, actually let me not clutter this up. Okay, give me a complete list of all the row exchange matrices. So what are they? They're all the ways I can take the identity matrix and rearrange its rows. How many will there be? How many 3 by 3 permutation matrices? Shall we keep going and get the answer? So tell me some more. 0. Okay, what are you going to do now? Switch rows 1 and 3, okay. 1 and 3. Leaving 2 alone. Okay, now what else? Switch, the next easy one is switch 2 and 3. Good. So I'll leave 1, 0, 0 alone, and I'll move number 3 up and number 2 down. Okay. Those are the ones that just exchange a pair of rows. This guy, and this guy exchanges a pair of rows. But now there are more possibilities. What's left? So there is another one here. What's that? It's going to change all rows, right? Where shall we put them? So give me a first row. 0, 1, 0. Okay, now a second row, say 0, 0, 1, and the third guy, 1, 0, 0. So that is like a cycle. That puts row 2 moves up to row 1, row 3 moves up to row 2, and row 1 moves down to row 3. And there's one more, which is, let's see, what's left? I'm lost. Is it 0, 0, 1? Okay. 1, 0, 0, okay. 0, 1, 0. Okay. Great. 6. 6 of them. 6p. And they're sort of nice, because what happens if I multiply 2 of them together? If I multiply 2 of these matrices together, what can you tell me about the answer? It's on the list. If I do some row exchanges, and then I do some more row exchanges, then altogether I've done row exchanges. So if I multiply, but I don't know. And if I invert, then I'm just doing row exchanges to get back again, so the inverses are all there. It's a little family of matrices that, like, they've got their own. If I multiply, I'm still inside this group. If I invert, I'm inside this group. Actually, group is the right name for this thing. It's a group of 6 matrices. And what about the inverses? What's the inverse of this guy, for example? What's the inverse? If I exchange rows 1 and 2, what's the inverse matrix? Just tell me fast. The inverse of that matrix is, if I exchange rows 1 and 2, then what I should do to get back to where I started is the same thing. So this thing is its own inverse. That's probably its own inverse. This is probably not. Actually, I think these are inverses of each other. Oh yeah, actually, the inverse is the transpose. There's a curious fact about permutation matrices, that the inverses are the transpose. And final moment, how many are there how many 4 by 4 permutations? So let me take 4 by 4, how many p's? Well, okay, make a good guess. 24, right, 24 p's. Okay, so we've got these permutation matrices, and in the next lecture, we use them. So the next lecture finishes chapter 2 and moves to chapter 3.